guys, you can go ahead and put away your homework, put away your books. Well, you can have your books on top of your desk, just have them closed. And you're going to want a sheet of paper out just in case I ask you a few questions. You want to be able to jot down some answers really quickly. How many of you like to take shortcuts? Just about everybody likes to take shortcuts, whether it's running to the mall and there's a road you can take that's a little bit quicker, or I know sometimes when I'm teaching PE and I see the girls that are running around the court, they like to cut off the corner so it's a little bit shorter. We like to take shortcuts all the time in our lives. Well, today we're going to learn a math concept that is kind of like a shortcut. We're going to learn how to shorten it, but you can also take it the long way. You can take the long way to the mall if you want to, but we tend to be in a hurry all the time. So today we're going to learn this little trick, maybe not really a trick, but we're going to learn this concept, and it's called exponents. You guys have probably seen them before, but we're going to be looking at them a little bit more today. And we've been talking about algebraic expressions and terms, so we're going to be using those when we get farther into this chapter, and we're going to be solving for things. We're going to be using these exponents all the time. And there's going to be a chart that's going to be handy for you guys that you're going to want to be able to look at, because we're going to be dealing with some really big numbers eventually with our exponents. But everybody, look up here at 5 squared. 5 squared, we've seen that before, and maybe you're thinking, okay, what is squared? I don't see the word squared up there. Well, does everyone see this 2? Everyone see the 2? Well, the 2, when we see anything that has that 2 above it, that means squared. But you're still probably thinking, okay, why do we have a little tiny 2 above our number? Well, this is an exponent. So this is our exponent. So I'm just going to write that right there so you can have that in mind. That's our exponent. But the 5 is really important too. In everything, you have to have a foundation. You have to have a base. So that's what our 5 is. This 5 is our base. So what does the 2 represent, Tiffany?
The exponent.
It is the exponent. And we're going to be seeing lots of these. You can see I have examples up here already. But this really doesn't mean anything to us. We can write things like this all the time if we wanted to doodle, but we want to know what it means. So anytime you have a number that is raised to another number, that's how we would say that, 5 raised to the 2nd power, or we don't really say 5 to the 2 because we have the handy word squared, and we'll be talking more about those a little bit later. But what this means is that this 5 is being multiplied twice. So it really means 5 times 5, because we have 2 of them. So anytime you see that, that's what you can know that's going to look like. So let's go ahead and look at this 3. Well, it's just like what we did right here. So Maya, how would we write this if we wanted to explain what that meant? 3 times 3, that's right. So it would be 3 times 3. Now this is a different problem because we have a different, do we have a different base or a different exponent, Anna Grace, from 5 squared?
A different base.
We have a different base because the 3 is different from the 5. Now do we have a same exponent, Jobin?
On which one?
On this 3 squared. Is the exponent the same as the 5 squared? It is, because it's the 2. So that's how you can know this is the exponent, the one that's above is the exponent, and the one that's on the bottom, that's the base. Remember that. Okay, we can look at this over here. And who wants to take a stab at reading this one? Any takers? Okay, Jobin, you look like you want to. So how would I write this out if I wanted to explain what it was?
It would be like y times y times y times y times y.
Y times y times y times y times y. That's exactly right. So you can see how we'll be using these, because if we had this written out, well, you don't want to write all of those y's all the time. You'll want to just kind of put them all together. So in this problem, this is your problem, Jobin. What is our base?
Y.
And what is our exponent?
5.
That is our exponent. Very good. Now this one over here, it's just like that one over here. How do we read this one, Anna Grace?
X squared.
X squared, because it has that too. And what does it look like?
X times X.
Is that it? That's right. X times X. X. That's very good. So you guys can look over here. So we've been taking our numbers that are exponents and we've been making them bigger. But what about this over here? What if I don't want to write out all of this y times y times y? What if I want to put it together because I'm making it into my trinomial or my polynomial? The easy way to do it is to just count it. So we have 1, 2, 3. So that's going to be our exponent. So y is our base because that's what we have. So we have y, and we know we're multiplying it 3 times. So it's going to be y to the 3rd power. So we saw that whenever it's to the 2nd power, it's squared. Can anybody think of maybe what a 3? Have maybe any of y'all ever heard that? Whenever we have a power to the 3rd, it is called cubed. So you'll want to know that, because I'll probably use that a lot. I'm probably not going to say very often y to the 3 power, y to the 3rd power. I'm going to say y cubed, 5 cubed, 7 cubed. Give me an example of something cubed, Maya.
3 cubed.
3 cubed. Jobin?
4 cubed.
4 cubed. Anna Grace?
7 cubed.
7 cubed. Tiffany?
10 cubed.
10 cubed. So any number that is to the 3rd power is going to be called cubed. Now, I have this right here, and we counted them and we put them together. So tell me, based on what we've been seeing, because this means they're multiplied together, so what if I had this? Y plus y plus y. Okay, that equals y cubed. Does everyone agree with that? I see some eyes saying no. We're not. That is not the same thing, because this is multiplication and this is addition. So never ever do we want to do that. So just make sure whenever you're putting them together that it is multiplication. So let's move to this one. This one's a little different because we have more than one base. We have a couple things here. So we have a 2 and an x. But how many 2's do we have, class?
1.
Just one. He's lonely. He's all by himself. So he's just going to be 2. And how many 3's, class? How many? I just gave you the answer. How many x's do we have, class?
3.
3. So that would be, we would write it as what, Anna Grace?
X cubed.
X cubed. You guys are catching on pretty well. So I want you to look at this one I have up here on the board and write it down on that piece of paper I had you get out, putting it together with your exponents. When you're done, you can just look this way. Okay, looks like everyone's done. So again, we had 2 different things. We had an x and we had y's. So we couldn't just put them all together because we have 2 different things. So Jobin, what did you do for our x's?
Well, I saw that there was 2 of them, so I put x squared.
X squared.
X squared.
Very good. And Maya, what did you do with the y's?
Since there are 3, I wrote y cubed.
Y cubed. Very good. So if you guys will go ahead and turn in your books to section 4.2.
Why didn't you use the raised dots?
That's a good question. Make sure you raise your hand whenever you have a question. And we can use the raised dots. Anna Grace asked a question that I was going to answer later, I was going to talk about later today. So here we know that yesterday we talked about different ways that we can write multiplication. And Anna Grace really liked her raised dots yesterday. I remember that. That's why she's asking that, isn't it, Anna Grace? Well, what are some other ways that we can write multiplication, Maya? Do you remember some different ways we can show that it's multiplication?
Parentheses.
We can use parentheses, so we could go all of them in parentheses like this if we wanted to. That would be a lot. What is one other way, Tiffany? Do you remember?
With the x multiplication sign.
With our x's. So we could use x's all the way down for it. I'm not going to show that. But you were right, we could use it, but whenever we have letters, remember we said we want to put it all together. Now, numbers, I did use a raised dot here, so you can kind of use it whenever you want, because we're not going to put these numbers together, because now I have a whole new number. Excuse me. Go ahead and do number 1 through 3 on page 112, and then we'll answer them together as a class. once you're done, you can put your pencil down and look up here. You okay, Jobin?
Yeah.
Okay. All right. Let's start with you, Jobin, on number 1. So it's asking you to tell the base and the exponent of each problem. So they gave you 7 cubed. Which one was the base?
7
And which one was the exponent?
cubed.
Cubed, or what's the number for
3.
cubed? Cubed. Oh, 3. Very good.
3.
Maya, number 2. The base
Oh, y.
and the exponent was 8. Very good. Yes, Jobin.
Can I use the bathroom?
You may.
May I?
You may.
Oh, thanks.
Can you tell us, Anna Grace, number 3?
The base is x,
And the exponent?
would be 3.
Did everybody agree with that on 1 through 3? That one was pretty simple. We did those, several of those up here. So very good job. Okay, we're going to be looking at the next section. You don't have to turn there just yet. I have some examples of these. But we're going to do number 5, and it is a long one. So this is going to show just why we want to be able to use our exponents when we can. So number 5 gives us 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. What if you had to write all of those every single time you had a very large number? You would be running out of lead all the time in your pencils. So we can now put, I just said we had 8 of these. So what can we do with that, Maya, to shorten it up?
You can write y and then a little 8.
Right, you can write y to the 8th power, because that's how we're going to say that. And that's easy. So go ahead and look at that section, and I'm going to have a few of you guys put these on the board. If I can get Maya to put number 7 on the board, so write out the problem they gave you and your answer. And Grace, if you can put 9 on the board, and Tiffany, if you can put 11 on the board. Jobin, right now we're working on section 4.2, 4 through 12. The rest of you guys be working on all of those at your desk. Okay, looks like everyone's finishing up. Jonathan's almost finished. You can go ahead and finish up. Let's go ahead and look at the board. And Maya is going to show us number 7. Tell us what problem you had and tell us what you did.
Okay. For number 7, we had 2 times b times b times b, and then I brought down the 2, and then I rewrote it as 2b cubed.
Very good. That looks good. Does everybody agree? I think so. You can erase that and have a seat, Maya. Thank you. And Grace, same thing. What you had and what you did.
I had number 9, and then I had 6 times c times c, which is equal to 6c cubed.
Very good. You can erase that and have a seat. And then Tiffany, go ahead and show us number 11.
I had number 11, and it was a x, y, 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 so I rewrote it as a squared x, y cubed.
Very good job. You can erase that and have a seat. And I want you to look at the chart in your book, because I can't make a chart like that looks quite as good as the chart we have. But we're going to talk about them up here on the board. So you have 6 cubed, 5 squared, x to the 5th, y squared, and 7 cubed. Now, go ahead and close your book, because we want to learn how to say these. Because we've been talking a little bit about them, but I think we might be getting a little bit confused when we say different things. So if I have this one right here, which one is my base, Maya?
6.
And which one is my exponent, Jobin?
3.
3. But another thing you might hear every once in a while is to the power. I think I've said that a few times, and I saw some faces that were kind of like, what? To the power? I don't know what that is. So we can also say 6 to the 3rd power, because that's the power that we're raising it to. So keep that in mind. So we're going to go through here, and each of you are going to take one, and you're going to tell me how you would read it, so we can see if we know how to say these, because we don't want to be going through our class and I say something or your classmate says something and we have no idea what we're talking about. So we're going to start at the bottom. How would we read this one, Tiffany?
7 cubed.
7 cubed, and what's another way that we could say it, Maya?
7 to the 3rd.
7 to the 3rd power. Both of those are right. Very good way to use that, cubed. Anna Grace, this one, how would we say this one?
Y squared.
Y squared or y to the 2 power. That just sounds a little weird. To this next one, Maya,
X to the 5th.
x to the 5th power, because we don't have a special fancy word. It's just to the 5th power. So anytime you have it like that, we can just go ahead and say the 5th, 6th, kind of like that. Not really a prefix, but we're not going to say what. You could say x to the 5 power, but 5th kind of flows better. This one, Jobin, 5 squared, because we have our special fancy word. And then this one, I'll do it for us, is going to be 6 cubed. But we've been doing all kinds of numbers. We've had 6 cubed, we've had squared to the 5th, but there's a few numbers that we haven't talked about yet, and they're ones that you're going to see, and they're very special. So 2 squared and 5 squared, even though they're both squared, we're going to get different numbers. But there are 2 numbers that we're always going to get the same thing with. So anytime we have a number that is raised to the 0 power, it could be 5, it could be your favorite number, whatever it is, 35, 75, it could be in the millions. If it's raised to the 0 power, well, remember we said that whatever it's raised to means how many times you're multiplying it together. So right here, we're not 0, we're just ran out of stuff. We're not multiplying it by anything. So anytime you have something raised to the 0 power, it is itself. It's that number. So 5 to the 0 power is 5. And this might be a rule you want to write down, because this was something I used to always get confused, and you're going to want to know this. So if I have 73 raised to the 0 power, what does that give us, Tiffany?
73.
73, because it is itself. So we've talked about to the 0 power, and the other one that has a very special rule is anything raised to the 1st power. So if I have 5 to the 1st power, anything to the 1st power always equals 1. So 5 to the 1st power equals 1. Actually, I just led you guys totally astray, and I got that very backwards. So go in your brains and erase everything that I just said, and let's swap that around. I got that mixed up. Even teachers make mistakes sometimes. So let's go backwards. I didn't think that was making sense, but I was plugging along with it. Let's go back to 5 to the 0 power. 5 to the 0th power is always, because we don't have anything to multiply it by, is always going to be 1. So anything raised to the 0 power is going to be 1. Let me see if you were able to erase that and fix it. Jobin, what is 73 to the 0 power? 1. So anytime you see the 0, just go ahead and put a 1 by it. 73 to the 0 power is 1. Okay, now take the rule that I had told you, and now we're going to switch them around. We have, let's do 5 to the 1st power is always, because now we're just multiplying it 1 time, it's going to be itself. So it's kind of identical. If you have that one, you might see like a little I. It's going to be identical to the base. So if we have, I want a really big number, 2,374 raised to the 1st power, what is the answer, Maya?
2,374.
2,374. Very good. I'm sorry about that. I hope you guys got that straight. So make sure you fix that in your notes where I told you that it was the opposite way. So we're going to be doing a few other things with these exponents, because right up until now, we've just been taking them apart and putting them together. And it seems kind of like, okay, we can take it apart and put it together. But what if we have numbers that we can actually put together. Like we actually know what it means to multiply by. Like Anna Grace noticed when we had 5 times 5. Well, we know what 5 times 5 is. It's 25. So once in a while we'll have numbers, or actually a lot of times we'll have something that may look kind of like this. 2 times 2 times x times x. So we're going to put those together in our exponent form. So Maya, can you help me out with the 2's? How would I write that? If I wanted to make it an exponent.
2 squared.
2 squared. And what would I do with the x's, Anne Grace?
X squared.
X squared. But we know that this means 2 times 2, so 2 squared, 2 times 2 equals, class, 4. So we really have 4 x squared. So anytime you have a number, you can go ahead and multiply it. We want to get it as simple as possible. 2 squared is not as simple as it comes. 4 is. Now why don't we go ahead and get a final answer on x squared, Maya?
Can't do anything more.
Why not? You mean I can't say that's 7?
No.
No. Do you know why, Jobin?
No.
Anybody? Okay. The reason we can't do anything else if we have an x squared or a y cubed or an m to the 5th is because we still don't know what the y is. We don't know what that x is. That x could be anything. So we can't put it any simpler. You just leave it with its exponent. So the only thing you simplify are the numbers that we have. Let's do another one. Let's do 5. Write this down on your paper and do it with me. 5 times 5 times y times y times y times y. So first things first, we're going to put this in our exponent form. Let's do those 5s. Tiffany, what do you have for the 5s? How are we going to make them an exponent?
5 cubed.
5 cubed. Everyone agree? And then y times y times y times y. Anna Grace, what did you do with those y's?
It would be
Y to the 4th, because we have 4 y's, right?
Right.
Yeah, very good. Okay, so we have y to the 4th, and we know that the y's are fine, because we don't know what the y's are. But what about 5 cubed? Well, we know what 5 cubed is. Maybe not right off the top of our head, but a good way to do this, we have it right here. We know it's 5 times 5. So what is 5 times 5? 25, and then times 5, 125. You guys are staying sharp on that arithmetic. Maybe a second guessing yourself. So the final answer would be 125 y to the 4th power. Very good on that. Look at problems 18 through 32. If I can get, Jobin, you haven't been at the board yet. Jobin, would you like to do 19 at the board?
Number 19.
Yes, sir. On page 113. Maya, could you please do 23? And Tiffany, do 25. The rest of you be working on 19, 21, 23, and 25 at your desk. Looks like you guys are getting the hang of it pretty well. Okay, once you're done, you can put your pencil down, and then we'll look this way at the board. Jobin, are you done over there?
Yeah.
All right, tell us what number you had and what you did.
So I had number 19. Number 19 said 4 times 4 times x times x. And since there was 2 4s, I did 4 squared. Since there was 2 x's, I did x squared. And 4 squared is 16, but I couldn't simplify x squared, so I just put them together and I got 16x squared.
Nicely done. You can erase yours and have a seat. Maya on 23.
23, I had 4 times 4 times 4 times A times A times B times B. I don't know if I said that 2 times. But then I simplified it and I got 4 cubed times A squared B cubed, and then I simplified 4 cubed and got 64, and then A squared B.
Very good. And Maya had one, we had 4 cubed, and she knew that 4 times 4 times 4 is 64. So if you're not sure on those just yet, make sure you're staying sharp on your multiplication. You can erase that and have a seat. Thank you, Maya. Tiffany, take it away on 25.
I had 6 times 6 times 6 times 6 times x. So I simplified the 6's. Since there's 4 of them, I wrote it 6 to the 4th power. Then there was only one x, so just brought that down. And then when I worked it out, I got 1,296x.
Right. Very good. And that was a very large numbers. We can see how exponents can make our numbers grow very quickly, and they can get very large very quickly. So you can go ahead and erase that, Tiffany. Thank you. Okay, we do have one last thing to look at, and we've been looking at it a little bit already, but we haven't just outright looked at it without addressing anything else. So up here we have 6 cubed, 6 to the 3rd power. Anna Grace, what does that mean?
6 times 6 times
6
6.
times 6 times 6. And remember, we can write this any way we want, but that means 6 times 6 times 6. So you look like you guys seem to get it that whenever we have that exponent, that's how many times the number is being multiplied, and we're just going to expand it. So we're going to look at that last section. I don't think we need to do too many more examples on that. So the last section, that's 36 through 41. Jobin on number 34.
34, okay.
Can you tell us how many times we're going to write out that 5? Because 5 is our base.
Since it's to the 4th power, we wrote it out 4 times.
4 times. So we would have 5 times 5 times 5 times 5. We're just kind of making it bigger so we can see exactly what it is we are looking at. Maya, on number 35, we have x cubed.
You write out the x 3 times.
So how would you say that? What would it be?
X times x times x.
Yep, very good. Anna Grace just helped me with this one at the board. So Tiffany, number 36. Now this one's a little different. If everybody's looking at number 36, Tiffany has x squared y cubed. So we don't just have one number or one letter. She has 2 different numbers and letters. So how would that go, Tiffany?
You do x times y times y times y.
Right. Very good. So however many times, whatever the power is, that's how many times we are multiplying it by itself. Number 37, Anna Grace.
Would be 7 times x times x times x times y.
Right. So you can see that we can just add these and make these as long as we want. You might get an algebra problem later in high school or when you're in college that has several variables. It might have 4 or 5 different letters and just one number. So it doesn't matter, as long as we know these few rules, we can just take them apart and figure out what it is that we're doing with them. And then I wanted to save the most exciting one for last. I think it's exciting, which is number 41, 2 to the 8th power. So everybody take out your papers and take out your pencil. Don't start yet. Whenever I say go on number 41, we're going to see how long it takes us to write out something to the 8th power. Go. Jobin is our winner over here. Let's see if it's actually legible, if we can see what he has. If he has it all the way. All right, Jobin is our winner on our fastest writer for today. Very good. So just a few questions to wrap it up. Jobin, if we have this right here, what is our base?
Our base is going to be 6.
Okay. And Maya, what is our exponent?
3.
3. And what is it telling us to do with those numbers, Anna Grace? To multiply. So we know that this is telling us we're multiplying something. You guys can go ahead and put your books away, and take out your homework notebook so you can write down your homework. Your homework for tonight is gonna be sharpening skills on page 113 and 114. Make sure you don't miss that back page. 2 through 18 even. 2 through 18 even. You guys can pack up and head to your next class.